Hello guys, welcome to another video from Theory channel. In this video we're gonna solve the fourth problem from second chapter of Sipser textbook, and in this problem we're gonna train how to actually simulate the context-free grammars and somehow construct a specific context-free grammar for a specific language. And yes, that's it. Let's solve it together. Okay guys, as you can see here, this is the question. Give context-free grammars that generates the following languages. In all parts, the alphabet is 0 and 1. So for the first one, part A, we must construct the context-free grammars for this language W, which W contains at least 3 ones. So actually, if we want to construct specific context-free grammars for this language, we need at least 3 ones. So here, if we consider that our start variable is s, we can start our language like this somehow. So we have s here, and after that we need at least 3 ones. In these cases that we need at least some number of some things, we can start like this. Place the at least point in your grammar like this. Here we need at least 3 ones, so I put 3 ones here, 1, 2 and 3. Okay, and after that we must somehow complete the places between numbers and outside them. So here we add some variables here and here and here and here. So in this case, we have at least 3 ones, and after that, the variable p can be anything. It can be 0, it can be 1, it can be epsilon, because in any of these cases, we have at least 3 ones. So here, p can generate actually 1, and after that, it can continue and generate other things. So we have 1p or 0p, or after that, it can generate epsilon somehow. So yes, this is the question and answer for part A of this question. So let me write it here. This is part A here. After that we have part B. Our language is W, which W starts and ends with the same symbol. So here for this language we have to actually somehow take attention to this note that some string, or better I say some character that the length of our string is only 1, they will somehow actually we can put them in this condition here. So for example, so this is part B, the string 1 or 0, these 2 strings have this condition. They both start and ends with the same symbol. So somehow we must put them in our context-free grammars. So here, if we consider that the start variable here is s, we can generate only 0 or 1. So it will become like this. And after that, if we want to generate strings with larger size, we can use from this method here. Our start and end symbol must be the same thing, so we put them both like this, 1 and 1, and in middle of them we can have anything here. We can have p, actually another variable that we call it p, and after that p can be anything. It can be 1p, it can be 0p, or it can be epsilon. In any of these cases, our string starts and ends with the same symbol. So yes, this is the context-free grammars for part B. For next part, for part C, our language is W, which the length of W is odd. So here we must generate all of the string with the length that is odd. So for part C here, we know that 0 and 1, the length of 0 and 1 is 1, and we can put them in our context-free grammars. So again, if we assume that our start variable is s, we have 0 and 1, and after that we have to generate all other strings that their length is odd. So it can be 3, actually it can be 5, it can be 7, and other things. So here we know that all of odd number we can write them like this. So if we assume that a is odd, we know that a is equal to actually 2k minus 1, or I can say that actually 2k plus 1, and k is in actually 0, 1, and 2, and yes, k is in this set here. So we can actually generate the odd and language like this. So based on this part, if we in every part we generate only 2 characters, and finally we put the middle character equal to 1 or 0, we have this string that the length of this string is odd. So here we can start like this. Actually it will become like this: 0p0 or 0p1, or after that 1p0 or 1p1, and after that or we can actually somehow simplify these context free grammars and actually change p to s. So it will become like this: 0s0, 0s1, 1s0, and 1s1. These context free grammars that we generate here, it can actually generate all of the strings that their length is an odd number here, because you can generate the first part, actually the mol of 2 and k with this part, actually, and after that if we want to add one string after that, we can use this part here. So yes, this is the answer for part C. And for next part, for part D, the length of W actually is odd and its middle symbol is S0. So here again we can start like this here for part D. If we assume that our start variable is S, we have again actually 0s0, 0s1, 1s0, and after that actually 1s1, and we know that our middle character must be 0. So we can actually choose from all these 4 options that we have here, and finally we can use only 1 0 in our language, and in this case our middle language will become 0. And yes, this is the answer for part D. For next part, part E, W, which W is equal to reverse of W, that is W is a palindrome. So for this case here, we can use from this method that I want to show you for actually part E. Our actually string here must be palindrome. Palindrome means if we start to read our string from the first or from the last, in both cases we will reach the same string. So actually we know that 0 and 1 have this condition. So S can be, actually let me change the color, S can be 0 or 1, and after that if we want to generate anything, we must generate it in both sides, in first and in end of our string. So if we want to generate 0, we must to generate it like this: 0s0, because we know that in this case we add 1 0 in the first of our string and another 0 at last of our string. So we have 0s0 and we have 1s1, and somehow we know that epsilon is a palindrome. Actually it has this condition here that epsilon is a palindrome. So yes, because if we read it in both sides, we have palindrome. Actually, we have epsilon actually. And yes, it is correct. And our context-free grammars will become like this. And actually for final part, part F, the empty set. So for final part, the empty set here, actually this is so simple. If we want to our string be the empty set, we must generate anything. Actually, better I say that we can't generate anything. And if we use from our context-free grammars, we always have a variable in our string and we can't terminate that variable. For example, if you look at all of the sample that we write here, somehow we could terminate our variable that we have in our string. For example, in part E, we can use from 0 or 1 and terminate S. For part D, again, we can use from 0 to terminate S. So if we want to have a context-free grammar that we can't terminate the variable, we can't actually use from anything, but the most simple answer for this question will become like this. S must generate S. Actually, if you look at this context-free grammars, it is correct and we can't generate anything with these context-free grammars and our language will become the empty set. And yes, this is the answer for fourth question in second chapter of Sipser textbook. We train how to construct the context-free grammar for a specific language. I hope you guys enjoyed this video and learned a lot of good things from my video, and you can use them somehow in your exam or in your practice, and I hope that it will be useful for all of you. And I hope you guys have a nice day, and I will see you guys. Goodbye.